Hello everyone, and welcome back to Net Mastery channel and another video in the Cisco series. In the previous video we speak a little bit about the spanning tree, and we said it's a protocol that is used to prevent the loop inside the LAN. But in this video we are going to speak about the spanning tree in more detail. Of course, the spanning tree subject is a big subject, and we need to divide this subject in different videos to make a shorter video and to make everything easy to learn. And in this video we are going to speak of the spanning tree, and of course we are not going to for the configuration or for the actual process of the spanning tree. We are just going to speak the different mode of the spanning tree and different port state of the spanning tree. First, what is the spanning tree? As I said, the spanning tree is a layer 2 protocol that is used to prevent the loop inside the LAN. And the STP it's created to avoid the problem that arises when a computer exchanges data on the local area network on LAN. As I said, when a computer sends a packet to another computer and that computer is not exist inside the LAN, then that packet may be become a loop inside the network, and it's go and back to switches, and of course it will make a broadcast a storm inside the LAN and make the traffic down, and of course affect the performance of the network. Then the spanning tree is used to actually prevent this broadcast storm and stop sending the traffic to stop sending the packet to switches and so on. And let's speak about the different the state of the STP. Please notice that this is the STP, the original version of the spanning tree. We have different version of the spanning tree, and of course the Cisco also customized that for himself, but here is the basic spanning tree protocol that how it works. For actually making a loop free path for the traffic inside the network, the spanning tree actually put different change the state of the ports to different state I can say here. The first one is disable. The disable, it's a port that is disabled and it's not participating in the spanning tree, or it doesn't forward any traffic. And then we can go to the blocking port. The blocking port actually it's participate inside the spanning tree, but it doesn't forward any traffic, and if it's receive any BPDU, it just process the BPDU, but it just discard that. It doesn't send it to any other switches. Then we can go for the listening port. The listening port actually from blocking port we can go to the listening port. When we actually connect the switch to another switch inside the network, this steps will be come one by one. As I said, the blocking, then to the listening. Listening means that the frame is still blocking, it doesn't send any traffic, but actually it's listening. It's trying to learn and to know about the network topology inside the LAN, and it's receiving of course the BPDU and redirect down this BPDUs to the processing module of the switch to take the decision. Then from the listening it will go to the learning. If it's when the BPDU is received and is processed, then switch will decide that to change the state of the ports, and in this case in the learning state actually port from the listening will go to the learning state, and in the learning state again it doesn't forward any traffic to prevent the loop, but it's decide to change the port state to one of this, to the blocking or to the forwarding. And then from the learning, it can go it can be blocking if it's need, and if it's need to be forwarding, then the port will go to the forwarding state, and in this case the BPDU will be forwarded, and the packet, of course, all of them will be forwarded to that port. And also the port will continue to receiving the BPDUs and the address table to updating the address table inside the switch. Receiving the BPDU means actually when we connect two different switch together, they are trying to send the BPDU to each other to decide the root bridge, and also to actually apply the spanning tree protocol. And this information here will be sent using this BPDUs, and this BPDU will receive to all switches. It's like I can say it's like a heartbeat. Every time this BPDU will be sent, and this BPDU will be processed to detect any changes inside the network topology. Then let's speak about the different spanning tree modes that we have two types. I can say the IEEE, the open standard, or the Cisco. The Cisco protocol, of course, in the next slide. Let's first speak about the IEEE. We speak about the IEEE, and it said it's Institute of Electronic and Electric Engineering, and it's used to standard the protocols. You can standard the different type of the electric and electronic devices. In this case, the spanning tree is also standard here, and the first and original spanning tree is IEEE 802.1d, and this is the first and original version of the spanning tree. Then we can say the rapid spanning tree. As you see, it's a rapid, it's more faster than the original spanning tree, and it's a next generation of the spanning tree here. And then we have of course, let's speak about this too, that they are using a single instance of a spanning tree. It means that you can only create a single instance of a spanning tree. It means when you select one switch as a root switch, then you cannot select another switch as a root. But with the multiple spanning tree protocol, MSTP, it's used to make a separate instance of a spanning tree. It means that one switch can be root for couple VLAN, for example, for VLAN 1, 2, 3, 4, and another switch can be root bridge for other VLANs, VLAN 10, 20, 30, 40, and so on. In this case, actually the MSTP, of course, is much better. They have their own advantage and disadvantage to each other, but these two protocol, actually the STP and RSTP, these two protocol is just used to using only one instance of a spanning tree, and we can use them inside the network. And if we apply this, we only have one switch as a root bridge, and it's a root bridge for all VLANs. But in the multiple spanning tree, of course, we can create a different instance of the spanning tree, and it can be one switch can be root for some VLANs, and another switch can be root for some other VLANs here. And then let's go speak the spanning tree modes in the Cisco switches. Of course, we have PVST plus protocol and RPVST plus. You can see the R is rapid, it's more faster, it's only take 2 seconds to converge, but the spanning tree protocol is the PVST plus protocol, and the Cisco, it's a default spanning tree that is enabled in all switches by default, and it takes up to 15 seconds to converge, and it's using the timer. but the rapid spanning tree doesn't use timer. It just, when it receives the BPDU and when a switch is down and up, it just sends a BPDU and will tell to other switches that it's a state, and then it takes only 2 seconds to converge and to select the different state of the ports. Okay, actually this is the last slide that I have in the spanning tree. And as I said that because the spanning tree is a little bit big subject, and we need to speak more in more detail about that to learn it better, and I just decided to create different videos for every section to make this learning easier and faster. And because of that, I just decided to finish this video here and to have a brief introduction about the spanning tree and different mode of the spanning tree. But in the next video we are going to speak about how the spanning tree works and how it's selecting the root bridge, how it's selecting the forwarding and blocking ports in the spanning tree. But in the Cisco spanning tree we have the concept of the root port and designated port, and we will learn how this switch actually take the decision about switches take the decision about the root bridge, and also about the different ports to different port states to apply this spanning tree protocol. Okay, let's finish our video here, and thank you for your watching. Please don't forget to subscribe our channel to learn more about networking and of course the Cisco networking. Thank you for your watching, and see you in the next video.